Hello everyone. Today I am going to be testing the EGR system on my 1979 Pontiac Firebird formula. This car has a 301 cubic inch engine, sometimes referred to as the 4.9 liter. It has a 4-barrel carburetor and a 4-speed manual transmission. EGR stands for exhaust gas recirculation. Why do we have EGR systems on some of our vehicles? We have them because when combustion temperatures reach around 2500 degrees, nitrogen oxides are formed during the combustion process. That's bad because nitrogen oxides are pollutants. The EGR system reroutes exhaust gases back into the combustion chamber. Why would we want exhaust gases rerouted back into the combustion chamber? Because exhaust gases don't burn. If they're in the combustion chamber, combustion temperatures will be lowered, and that will result in reduced production of nitrogen oxides, and that's good. GM prescribes 2 tests for testing the EGR system, and they're very simple tests and actually don't require any tools, but I've got some that I'm going to use anyway. The first tool I have is this vacuum gauge, which I picked up for I think $15 at Harbor Freight. Well worth the money. Another tool I'm going to use is the information from the vehicle emission control information sticker or label that you should be able to find on whatever vehicle you're working on. And what this shows is that we have an EGR valve. This EGR valve is connected to the carburetor by the single vacuum line. If we look at the actual engine, we can see this in real life. We have the carburetor, and then coming off the carburetor right here at this port, we have this vacuum line, comes down around, comes up into here, and into our EGR valve. The final tool I'm going to use, I can't recommend highly enough, and that is the service manual, the factory service manual. Whatever vehicle you're working on, see if you can get the factory service manual for it. This is the one that I use for this car. Can't recommend it enough. When I decided to test my EGR system, I first consulted my Chilton manual, then I consulted my Haynes manual, and between the two of them, it left me very confused. I then consulted ProDemand, which is an industry subscription service for automotive technicians, and that confused me even more. Finally, I pulled out the service manual, and using all 4 of those things together, I was able to determine what kind of system I had and how to test it. GM had 2 systems that they used. One is a ported EGR valve system. In those systems, the EGR valve has just a single valve in it. It's open or closed, and it's modulated by engine vacuum coming off of the carburetor. The other system GM used is a back pressure system. These systems, which this one is, there's actually 2 valves inside the EGR housing. One of these valves is modulated by the engine back pressure. The other valve is modulated by the engine vacuum, again coming off of the carburetor. Now we don't need EGR or exhaust gas recirculation going on all the time. We don't need it when the engine is cold. We don't need it when the engine is at idle. And we don't need it at wide open throttle. When we do need it is when we're cruising along under normal load conditions and normal engine RPMs. To do these tests, the engine has to be running and it should be at normal operating temperature. Now, I'm just starting this, but this engine has been running for about the last half hour off and on, so it should be up to normal operating temperature in just a minute. So if you'll start, I'll get things started. preliminary things. We need engine vacuum coming off the carburetor, but we don't need it at idle. So I'm going to hook my vacuum hose up to the carburetor vacuum line, and we're going to see how much vacuum we have coming off of it at idle. Then I'll raise the RPM. We'll be able to see what happens with that. Alright, so I've got the vacuum line hooked up to the gauge. You can see we're at idle, we've got no vacuum. I'll raise the RPM a little bit. Okay, so I hooked the vacuum gauge up to the vacuum line coming off the carburetor at idle, no vacuum. At higher engine RPMs, you saw that we had nice, steady, consistent vacuum, which is good. That means that the EGR valve is getting engine vacuum from the carburetor when it's necessary. Now the first thing I want to show you about this system is if I reach down underneath the EGR valve here, I can actually feel the diaphragm that opens and closes the valve into the exhaust port. So if I push up on it, that's like applying the EGR valve, opening the valve. We'll see what happens with the idle. So did you notice that? When I pushed up on the diaphragm or opened the valve, the idle became rough, unstable. Because as I said, we don't need EGR at idle. So for the first test, all GM says to do is to feel the diaphragm, raise the RPM, and just see if the diaphragm moves. So that's what I'm going to do. Alright, so when I increased the RPMs, the diaphragm moved up, which opened the EGR valve, which is what we want. Raising the RPM simulates normal driving, cruising conditions. That's when we want EGR to happen. The second test, GM prescribed setting the RPM, holding it steady at cruising RPM, so about 2,000 RPM. And then while holding it steady, disconnecting the vacuum line from the EGR valve. Now when we do that, since both back pressure and engine vacuum are required to open the EGR valve, if it's already open and we disconnect the vacuum line, the valve should close. When the valve closes, we should actually hear the RPMs going up. Once that happens, I'll plug the EGR valve back in, and RPM should go down. That might seem a little counterintuitive that when the EGR valve is closed, engine RPMs are higher, and then when the EGR valve is open, RPMs are lower. But think about it, when the EGR valve is open, we're getting combustion gases, burnt, spent combustion gases going back into the combustion chamber. So we're not getting as complete combustion or as much combustion or as much power from the combustion as we do when the EGR valve is closed and it's just burning the air fuel from the carburetor. So let's test it and see what happens. Alright, shut the car off. Okay, so everything went as it should have. When I raised the RPMs and held it steady, with everything hooked up, EGR kicked in. There was exhaust gases flowing into the combustion chambers. When I unplugged the vacuum line from the EGR valve, RPMs went up because there were no more combustion gases, and now we were just getting pure air-fuel mixture into the combustion chamber for better combustion. And then when I plugged it back in, the RPMs dropped again. Now the manuals say that when you unplug the vacuum line from the EGR valve during this test, that the RPMs should go up about 150 RPM at 2000 RPM engine speed. When you plug it back in, it should drop back down. That's pretty much what happened. We didn't have a tachometer. We could have had a tachometer hooked up to it to see it precisely, but it did what it was expected to do. I think we'll probably pick up a new EGR valve for this engine, just because the one that's on there is the original one and might get a little bit better performance with the new EGR valve. And just to see how well this is functioning, we'll compare it to a brand new one. When I get the new one, I'll make another video of the replacement, see how that goes. And I want to thank you for watching this video. If you enjoyed it, or if you have any questions, let me know in the comments section below. This is actually the first video of this type that I've ever tried making, so any feedback that you care to give me would be great. If I get enough people who are interested or would like some more videos, I'll be working on this car for a long time. There's going to be a whole new engine put in it, and there's other stuff that needs to be done with it. So if you, again, like this video, please subscribe. Let me know your thoughts in the comments, and thank you for watching. I hope you learned something. Bye-bye.